Okay, so the addition rule for mutually exclusive events. So we're going to go through a few questions. We're going to talk about whether they're mutually exclusive, how do we work out the total probability, and then at the end we're going to come up with a couple of rules for finding probability of mutually exclusive and non-mutually exclusive events. Okay, so the first one is we've got an experiment. We got a single six-sided dice is rolled. What is the probability of rolling a 2 or a 5? So the first thing I want you to think about is this mutually exclusive or not? And it is, and if we draw our Venn diagram of this, we can see that we have the event, which is a 2, and the event, which is a 5, and there's one way we can get a 2 and one way we can get a 5. Okay, there's no overlap between those two events. So what's the probability of getting a 2? Well, it's one outcome out of 6 on the dice, so our probability is 1/6. Same with the probability of 5. We can see that we end up with 1 out of 6 again. That means our probability of getting a 2 or a 5, okay, is 1/6 plus another 1/6. Okay, that's probability of 2 plus the probability of 5, which is 2 out of 6, which is the same as 1/3. And again, you guys could work that out without having any kind of doing any really calculations. But just so we can step it out a little bit, it's going to help us come up with some rules. Second experiment, we have a spinner that has equal sectors coloured yellow, blue, green, and red. What is the probability of landing on red or blue after spinning the spinner? So again, this is mutually exclusive because we're looking at red or we're looking at blue, and there's one outcome where we get red, one outcome where we get blue. So our probability of red, okay, is 1 out of 4, and our probability of blue is also 1 out of 4. Therefore, our probability of red or blue, okay, is 1 out of 4 plus 1 out of 4 equals 2 out of 4, which is the same as 1/4. Oh, sorry, what am I doing? 1/4. Sorry, wrote down 4 too many times. 1/2. Okay. Third experiment. So far really easy. Okay, it's still going to be pretty easy for the moment. Okay, a glass jar contains 1 red, 3 green, 2 blue, and 4 yellow marbles. Okay, so altogether that's 10 marbles. If a single marble is chosen at random from the jar, what is the probability it is yellow or green? So again, we're looking at mutually exclusive events because we're only talking about the yellow and the green outcomes. Okay, so that's yellow, that's green. There's 4 yellow, and we've got 3 green. So our probability of yellow is 4 out of 10. Okay, and our probability of green is 3 out of 10. Now notice that I didn't simplify down this fraction even though I could. I could have split that into 2/5, but I haven't because I want to keep those fractions both as denominators of 10 because then when it comes to adding it together, it's a lot easier. Okay, so now my probability of yellow or green is 4 out of 10 plus 3 out of 10, which is 7 out of 10. Okay, so far all of the events we've looked at are mutually exclusive. And obviously you can work out the probability of putting them together is we're just adding them, which is really easy. But we're going to come through and we're going to look at this next event, which is a not mutually exclusive one. So a single card is chosen at random from a deck of 52 playing cards. So this is quite similar to one of the examples we were looking at the other day. What is the probability of choosing a king or a club? Okay, so in this case, we've got king and we have a club. And we know that there's one card which is both a king or a club. We know there's 3 other kings in the deck. And we know that there's also 12 other clubs in the deck. And if you're not really familiar with your playing cards, that's not a big deal, but I would say, it's an important thing because it does come up a lot in exam questions and things like that. So try and have some kind of an understanding. Okay, we should see that our if we look at the Venn diagram, our total probability of a king or a club, okay, is 3, 12, 15, 16 out of 52 altogether. Okay, but we don't want to always have to do a Venn diagram every time we're working out a mutually exclusive event. We also want to be able to do this without the Venn diagram. So if I was just working this out, based on the question, I know the probability of kicking out a king. Well, I know there's 4 kings in the deck, so that would be 4 out of 52. And I know my probability of picking out a club. Well, there's 13 of those in the deck, so that would be 13 out of 52. And I know that there's 1 king and club, okay? And that little upside down N, that stands for and when we're doing probability. So I know there's 1 king and club in the deck. Why do I have 15 for that one there? There you go. Change that. Make that 52. So all together now, if I wanted to work out these probabilities without having done the Venn diagram first, my probability of a king or a club, and that U sign, that stands for or, king or a club, would be 4 out of 52 plus 13 out of 52. Okay, so the probability of a king plus the probability of a club minus the probability of the king and the club. Okay, and so that gives me 17 over 52 minus 1 over 52, and then I end up with 16 over 52, which is the same as my answer over here. Okay, now why do you have to minus off that 1 out of 52? Well, you have to minus it because otherwise you would be double counting that in both the kings and the clubs. Okay, so you would be including that in both events, whereas really there's only one of those. Okay, one where there's a king and a club. So you need to subtract that off. Alrighty, last question. On New Year's Eve, the probability of a person having a car accident is 0.09. The probability of a person drinking while intoxicated is 0.32. And the probability of a person having a car accident while intoxicated is 0.15. What is the probability of a person driving while intoxicated or having a car accident? So I'm going to work this one out without doing the Venn diagram first. So first thing I'm going to do is write down my probability. So the probability of someone having an accident is 0.09. The probability that someone's driving while intoxicated is 0.32. And the probability of someone having an accident, I'm just going to use A, and they're intoxicated is 0.15. Okay, so then we want to find out what is the probability of someone driving while intoxicated or having a car accident. So in this case, we can use that same kind of idea with the probabilities we did before. Now this case, again, is not mutually exclusive because you're looking at that combined probability where you've got that and event, accident and intoxicated, which we don't have with mutually exclusive. Okay, so if we want to work out our total probability of an accident or they're intoxicated, okay, it's the probability of the accident plus the probability that they're intoxicated minus the probability that they're both. Okay, because then we would be double counting that both part. So we end up here with 0.09 plus 0.32 minus 0.15. Now that would give me 0.41 minus 0.15. Chuck that in here. 0.41 minus 0.15, and I get 0.26. Okay, so that would be the probability of the person having the accident while driving while intoxicated, or the probability of a person driving while intoxicated or having a car accident on New Year's Eve. Okay, lovely. So for summary, okay, for mutually exclusive events, okay, the probability of A or B, okay, is equal to the probability of A plus the probability of B. And that's because your events do not overlap, okay? You're not double counting any of the probabilities in there. Now, for non-mutually exclusive events, okay, your probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And that's because you do have that overlap where you would be double counting your probability, so you need to subtract that off. Okay, and these are your rules for addition law for probability. Alrighty, hope that's been okay. Enjoy the rest of your weekend.